In this video, we're going to look at the application of surds. Now, if we take this question here, it says the diagram shows a triangle DEF inside a rectangle ABCD. We need to show that the area of DEF is 8 centimeters squared, and we need to show all of our working out. So the first thing to notice for a question like this is that all the corners of a rectangle is a right angle. So we're going to draw that in. So we've got a right angle here, got a right angle here, got a right angle here. So what we have is 3 right angle triangles inside this rectangle. So the issue that we have initially is I don't know what this distance DC is. But before I do that, I'm going to say, well, I can easily work out what the area of this triangle BFE is. That's just going to be 2 times 2 divided by 2, which is 4 over 2, which is simply 2. So what I want to do now is work out what DC is. Now I can do DC by saying it's going to satisfy Pythagoras' theorem. Side opposite the right angle is called the hypotenuse. So it's going to be 2 root 10 squared, which is the hypotenuse squared, is equal to the shorter side 2 squared plus DC squared, which I called X. So let's do 2 root 10 times 2 root 10. 2 times 2 is 4. Root 10 times root 10 is 10. 4 times 10 is 40. So I can now say that 40 equals 2 squared is 4 plus x squared. So I can say x squared is 40 minus 4, which is 36. And then we square root that. So I can say that x is 6 centimeters. So I know what DC is now. So I can work out the area of triangle DCF now by saying it's going to be 6 times 2, because the base is 2 and the perpendicular height is 6. So 6 times 2 divided by 2 will give me 12 over 2, which is 6 centimeter squared. So now this is 6 centimeters squared here. This is 2 centimeters squared. And we want to work out what this triangle ADE is. Well, AD is the same as BC, meaning that's going to be 4 centimeters. DC is exactly the same as AB. If that's 6 centimeters and that's 2 centimeters, this has to be 4 centimeters. So we can now work out the area of this triangle, which is 4 times 4 divided by 2. So 16 divided by 2. That's going to be 8 centimeters squared. So the area of the rectangle is going to be 6 times 4, because the length DC is 6 centimeters and the width is 4. So we can say that the area of the rectangle is going to be 6 times 4, which is 24. Then we need to now do 24 minus the sum of the area of the other 3 triangles. So that's going to be 6 plus 2 plus 8. And then that's going to give me 24. 6 plus 2 is 8, plus another 8 is 16. And then 24 minus 16 is 8 centimeters squared. And that's what I was required to show. Here's another question. You can try the question, pause the video, and when you're done, I will go through my work solution. Okay, welcome back. Here we've got a question that says a trapezium ABCD has an area of 5√6 centimeters squared. We need to work out the length k. So the first thing we need to know that about a trapezium is the shorter parallel side is called A, the longer parallel side is called B, and the perpendicular height is known as H. Then what we can say here is that the area of a trapezium is half A plus B times the height. So we got 5√6 equals to a half times 4. Now B is k and the height is √3. Now to get rid of this half, we're going to times both sides by 2. Then the half and the 2 will cancel out. That's gone. So 2 times 5√6 will give me 10√6. And then I get √3 times 4 plus k, like so. So now what I can do now is say 10√6 equals 4√3 plus k√3. So because I want to find k, I need to make k the subject. So that's going to be 10√6 minus 4√3. That's going to be equal to k√3, right? So that's going to be equal to k√3. Now I'm going to divide by √3 to find k. So k is going to be 10√6 minus 4√3. And we're going to divide all of this by √3. Now you should know that you can never have a surd on the bottom. So we get rid of that surd by the process of something called rationalizing the denominator. So I'm going to times the numerator by √3 and also the denominator by √3. But let's do this step by step on the side here. So what we're doing is 10√6 times √3. So 10 times √6 times √3. So that's going to be 10 times √18. Now that can be separated to 10 times √9 times √2. That's going to be 10. √9 is 3, and then we get times by another √2. So we get 30 √2. So now we want to do 4√3 times √3. So 4√3 times another √3. 4 times, well, √3 times √3 is simply 3, and that's equal to 12. So now we can say that k is 30 √2 minus 12. Now don't forget the denominator, √3 times √3 is simply 3. So k, now this we can take 3 out as a common factor, so we end up with 10 √2 minus 4. And we're going to divide all of that by 3. So we can cancel the 3's out. So I'm left with a 1 and a 1. And I end up with my final solution, which is going to be 10 √2 minus 4.